Enroute considerations.
Although there are typically no unique en route procedures required during an ETOPS flight, the flight crew's responsibility for monitoring the airplane's position, fuel, and system status takes on increased importance. The flight crew must also confirm the weather status at the designated ETOPS alternates before passing the ETOPS entry point. If alternate weather conditions are expected to be below operating minimums during the required validity period, the flight crew should coordinate with dispatch to determine a new ETOPS alternate and/or reroute the flight. An updated flight plan should also be produced. It is a good idea for the crew to continue monitoring alternate weather as the flight progresses. However, there is no requirement to reroute if an ETOPS alternate becomes unavailable after the flight has entered ETOPS airspace. As with any other flight, if an event does occur on an ETOPS flight, the flight crew must make a decision whether to proceed, divert, or turn back. The crew is not bound by the ETOPS rules to any specific course of action. They must evaluate the situation and take appropriate action based on the actual circumstances. For an ETOPS diversion due to an engine failure, the flight crew must determine the best speed, altitude, and thrust rating for the engine in operative flight to the alternate. Normally, such a diversion would be flown at the approved ETOPS planning speed. However, the crew may select a different speed if judged to be a better choice for the prevailing operational conditions. If time is the greatest concern, the decision might be to fly at maximum continuous thrust at the highest altitude possible. If time is not the greatest concern, the decision might be to fly at maximum cruise thrust, resulting in a longer diversion time and a lower cruise altitude. The FMC provides ETOPS engine and operative speed guidance on most ETOPS airplanes. The FMC ETOPS performance predictions, when available, include engine-out altitude capability, as well as diversion fuel and time required to the selected alternate. This information may also be available in Chapter 3 of the Flight Planning and Performance Manual, or from manufacturers' supplied performance software tools. For airplane models with an FPPM, Chapter 3 includes charts to determine engine-out altitude capability, diversion fuel, and expected cruise performance for a range of ETOPS speeds. Altitude capability charts are provided for both maximum continuous thrust and maximum cruise thrust. Note that the effect of thrust selection can be significant. This should be taken into account when deciding on a course of action. The altitude correction for anti-ice bleed should be considered as well if icing conditions are expected. The FPPM also provides one engine inoperative en route diversion charts. These charts allow the quick calculation of diversion fuel and time required for different engine-out cruise altitudes. The critical fuel scenario check in the flight plan ensures that fuel should not be a concern if the diversion is flown at the approved ETOPS planning speed, and the diversion is to the closest ETOPS alternate listed in the flight plan.